Hello, everyone. My name is Guilherme, and today I'll present the paper Tree of Thoughts, Deliberate Problem Solving with Large Language Models. It was written by a team of researchers from Princeton University and Google DeepMind. And yeah, I'll go over it, try to be concise, and in the end, we can maybe discuss it a little bit. All right, so the paper is pretty straightforward, I think. It presents this technique they call tree of thoughts, and they compare the performance of this technique in association with language models. They compare the performance of it with different techniques, other techniques that are commonly used with language models, like, for example, chain of thought. Yeah, that's basically it. So the context is that supposedly we humans have two different modes in which we engage with decision making. They call the first one the system one, which is this fast, automatic, and conscious mode, and the system two is the second one, which is a slow, deliberate, conscious mode. And they say that the way that language models work, this generating token by token from left to right, is more akin to the system one, whereas this tree of thought that they present here is more like the system two. So as you guys probably know, there are a lot of tasks that language models usually don't perform very well. One example is mathematical reasoning. So even simple arithmetics, usually they don't perform as well as they could, or we would hope them to. And this technique aims at least improving the performance of these models in this kind of task. So here they illustrate the different techniques that are commonly used with language models. This is the normal input-output prompting. Then we have a chain of thought, which is we basically ask the model to provide intermediate steps before giving the output. So not only the output, but intermediate steps that advance from the input towards the output. And then we have self-consistency with chain of thought, which is chain of thought, but we sample many times, and we have some sort of classification here, could be implemented in different ways. And we vote on the best outputs or the best output, and we choose the best output, but the chain of thought that generated it as well. And then we have the tree of thoughts that they are presenting here, which is it's similar to self-consistency with chain of thought, but it allows for more combinations of thoughts. So how it works is we give the model an input, and we ask it to generate one intermediate step, right? And we can repeat this process as many times as we want to get as many thoughts as we want in that step. So in this case, we would prompt the model 3 times. We would get 3 different first thoughts here. And then we would ask the model to evaluate these thoughts that it generated. So we would ask it if that thought, it really depends on the task at hand, but if it meaningfully advances towards a reasonable output would be the idea here. And then the model evaluates these thoughts, and we repeat this process to the thoughts that it evaluated as being good or promising. And then again, we repeat as many times as we want thoughts on that step. So we would sample this many times here. We would again evaluate the thoughts in this intermediate step. We get the best ones. Again, ask the model to generate another intermediate step based on the thoughts that it previously generated, and so on and so forth until we get to the final step here. And so things that are important here, pruning. So we don't have to take into consideration the thoughts that were evaluated as being bad. So we don't expand these nodes. And this obviously generates a tree, right? A tree of thoughts. And we can implement different search algorithms to look in this tree until we get to the final output. In this paper, they use the two classical ones, so depth first search and breadth first search. Again, the choice depends on the task, and that's another really cool thing about this model, this technique, is that it allows for a lot of versatility. You can in the steps that compose this technique, you can try different algorithms and so on. So it's really cool in that sense. Um, let's see. Here they define more technically the techniques. Yeah, so every instantiation of a tree of thought, you have to answer these four questions here. So how to decompose the intermediate process in thought steps, how to generate potential thoughts from each state, how to heuristically evaluate states, and what search algorithm to use. So thought decomposition is basically trying to understand what would be a good definition of a thought in that context. So you need something that is large enough for it to be meaningfully evaluated. So usually a single token wouldn't mean much. You wouldn't be able to say if it's a good thought or not based only on that. But it also can't be so large that it can't be reasonably evaluated. And also things that are too large. So here it gives an example of generating a whole book, right? It would be too big to be coherent. So it will also be really hard to evaluate how good that thought is. Um, the second one, thought generator, is how you're going to generate the thoughts. So you can either sample, which is what I told you guys before. You just repeat the process of asking the model to generate an intermediate step. Or you can just give it one single prompt and propose it to generate like any thoughts. So in a single prompt, you ask it to generate 5 or 10 thoughts or whatever. And it again depends on the task. So the sampling method works better if the thought space is rich, uh, because samples lead to more diversity. And the proposing method works better if the space of thoughts is more constrained because it avoids duplication, right? So if you provide just a single prompt, the model will not give you uh, 5 thoughts that are the same one or very similar to each one. It will try to avoid duplication. Then you have the state evaluator, which is how you're going to say if a thought is good or bad. And you can try different things here. They separate between value and voting. So valuing would be just giving an evaluation based on the thought alone. So you can do this either by giving a scalar value or a classification. So sure, likely, impossible. And voting is comparing the thoughts in that intermediate step with each other. So again, it depends on the task. There will be examples here where they've used the value, and another example where they use the voting system. And finally, the search algorithm, which is basically how you're going to search the tree for the best results. Yeah, here they talk about the advantages that they see with this method. The first one is generality. They say that you can see the usual techniques that are used, like input-output, simple input-output, chain of thought, and chain of thought with self-consistency as merely special cases of tree of thought. So they would be trees of limited depth and breadth, for example. Modularity. So again, you can divide the tree of thoughts into these different modules, and you can change how you're going to do each of these modules, depending on what kind of thing you're trying to do. Adaptability, so different problems allow for you to adapt this technique in different ways and accommodate to resource constraints and capabilities of the language model and things like that. And convenience, which is something that I found really interesting, is that this technique doesn't require you to use anything else besides the own language model. So you ask the language model to generate intermediate steps. You ask the language model to evaluate these steps. So that's really cool. You don't need to do any extra training or use a different model to classify the thoughts and things like that. So that's really cool as well. So finally, the experiments they tried this on. They tried it on 3 different tasks. The first one is game of 24, then creative writing and 5x5 crosswords. So let's start with game of 24. Is a simple mathematical game where you give the model 4 different numbers, and you ask it to provide an equation with only that contains only these 4 different numbers and the basic arithmetic operations, so plus, minus, multiplication, division, and this equation needs to result in 24, right? And so this is how it looks like, an instantiation of the tree of thought in this case. So you give an input to the model and you ask for possible next steps. The model gives you a few different possibilities. These would be the thoughts in that intermediate step, right? And then you get each of these thoughts that it generated. You ask it to evaluate. In this case, it was asked to evaluate if these numbers that were left after doing the operation it provided, it could potentially reach 24, right? So evaluate if giving numbers can reach 24. So in this case, it thinks it is impossible to reach 24. So this is a thought that will be pruned. You won't even consider this anymore. This one, it thinks it is possible to reach 24. So you'd use this to generate new thoughts, a new intermediate step, and you repeat this process, right? So you get each of these, ask the possible next steps, generate the next steps, evaluate them, so on and so forth until you get to the final output. So this is how they set up the task. They got a bunch of random games and so on. Yeah, so these are the results comparing the tree of thoughts with other techniques, and it performed incredibly well. So this is simple output prompt, chain of thought, and chain of thought with self-consistency. Then we have tree of thoughts with this p equals 1 here is the number of thoughts that you take into account in each intermediate step. So in this specific case, they've used breadth first search. So in breadth first search, you kind of memorize a few of the states in that step for you to search them later on. So this b equals 1, you consider only one, the best state in that intermediate step, and b equals 5, you kind of memorize the 5 best states in that intermediate step. Um, this refine, I don't remember what this refine is. I think you ask the model to, instead of generating a random, yeah, I think you ask it to evaluate if it is coherent, and if it's not, you make it generate again, something like that. But yeah, anyways, even with that, the tree of thoughts performed well above every other technique. Yeah, this is also really interesting. So this is the step in which the technique failed. So chain of thought and tree of thought, which with b equals 5, so considering the 5 best thoughts in each intermediate step, and more than 60% of the games it played, the chain of thought failed already at step 1. So that's really interesting. And tree of thought uh, got you the answer in most of the cases, right? Yeah. Tree of thought with a breadth of b equals 1 already achieves a success rate of 45%, well above the others. Then we have creative writing, which is so they basically generated 4 different sentences, and they asked the models to create 4 paragraphs, and each paragraph must end with one of these 4 random sentences, uh, respectively. So the first paragraph must end with the first random sentence, the second one with the second random sentence, and so on. And yeah, the what I find what I found really interesting with this one is that it has only one intermediate step, right? And the intermediate step here is actually creating a plan for what the final paragraphs will look like. So uh, one plan, for example, would be, so you'd give the first sentences, right? It isn't difficult to do a handstand if you just stand on your hands. The second one, it caught him off guard. That space smelled of seared steak, and two others. And you ask the model to make a plan on how it would write the paragraph. So a plan 1 is introduce and explain the technique of doing a handstand, switch through to a story about an astronaut's first time in space, and so on. And then it creates a lot. You sample it, you ask it to create a bunch of different plans. Then you ask it to evaluate which plans are the most promising ones, and the plan that it evaluated best is the one that's going to be used to generate the final 4 paragraphs. So in this case, the second plan was voted the best. So you use it to write 4 different paragraphs multiple times, right? And then you choose the 4 best paragraphs that use this plan. Yeah, these are the results. Uh, in this case, it didn't perform that much better than IO and COT. This refine is they've asked the model if uh, the results are coherent, and if it's not coherent, you ask it to make it coherent. So it refines the previous results. So it tends to improve somewhat the output. But yeah, it performed better, but not that much better. Um, this is the evaluation of the paragraphs by GPT-4, and this is the evaluation by humans. So a bunch of people just evaluated the how well the paragraphs were written. Most of them thought that tree of thoughts performed better than chain of thought, but uh, yeah, a lot of them also found it to be similar, right? So interesting, but not that huge a deal as it was with the game of 24, for example. The final task that they tried this on is mini crosswords. So they got a bunch of games of 5x5 mini crosswords. And the input in this case are the clues, right? So in crosswords, you have the clues, right, of what the word is should be in that space. And this is the input. So this task is the one that is, I think, they created a kind of complicated pipeline. They added quite a bunch of things. So yeah, it's a little bit complicated. They inputted the clues, and a thought here is a bunch of words that would complete the the crosswords, but then they do this aggregation, which is somehow evaluating these words to see the ones that should be tried first, the ones that are most promising. So the ones that are certain, for example, or almost certain, the ones that are hardly the right word, and so on. And then they do this aggregation and create this list, this ordered list of words should be tried. And it goes through that word. It creates new words based on considering that word already. So the next words, and uh, and then this evaluation, they use the state of the board in that step to to define the letter constraints. So it's a kind of complicated process, but basically seeing if the words that were put into the board allow for they combine correctly, right? There's no like wrong letters, places where they overlap and things like that. And then it evaluates and see if that state is a reasonable state, if it could eventually lead to the completion of the crossword or not, the crossword or not. And yeah, in this case, they use depth first search, which I think is made all the difference here in this case, because I mean, it very naturally translates to this case, I think, because uh, you can you backtrack to the last state if the word that you got is not the correct word, but you can simply change the last word, right? You don't uh, you keep all the words that came before. So backtracking here, I think, made all the difference. Um, yeah, the success rate here. So they evaluated the success in terms of letters, in terms of words, and in terms of games. So letters in the right places, words in the right places, and the completion of the game. So Simple IO performed very badly, couldn't complete any game, and even the other success rates were really bad. Chain of Thought performed considerably better, but yeah, not that much better, right? It only completed one game, and the Tree of Thoughts performed way better, completing 20% of the games and um, being able to correctly identify the letters and the correct words. Um, This best state is are some tweaks that they did with the pipeline. The best state is instead of asking the model to evaluate uh, if that state is good or bad, you already tell the model what the best what which is the best state in that intermediate step. So yeah, it makes it better, but it's not that much better, right? I don't know. Maybe you'd expect it to make more of a difference, which makes me think that the model is being really good at evaluating the current state, right? Uh, then they took out the pruning, so you don't prune the states that the model deemed impossible or not good enough. You don't do any pruning, and then you don't do any backtrack as well. Um, but even after doing these things, it performed better than simple IO and COT, which is interesting. Uh, but yeah, these are the three tasks they tried this on. I think my only kind of criticism to the paper, I think, is uh, this crossword puzzles, because I mean they didn't simply use this technique to solve the crosswords. They've tried. They added a bunch of other things as well, right? And so I think it quite helped the technique to perform better. Uh, but even then, it's quite interesting. It's interesting how well it translates this the search algorithm, how well it translates to the task of solving a crosswords. Um, yeah, I think that's basically it. They do some considerations in the end. They say that drift thought would not be necessary for many of the simple tasks that GPT already does really well, but it could allow to more specific tasks that benefit from this kind of exploratory um, pipeline. Um, so as we saw the mathematical reasoning, things like that, it could significantly improve the performance on these tasks. Um, yeah, I think that's it. If you guys want to make any comments.
Yeah, okay, I think very good, Guilherme. Really good presentation. Does anyone have any comments?
I think the most thought-provoking thing here was like the last sentence. Like if you see in like limitations and future directions, like, oh, this work focuses on using an off-the-shelf LM and fine-tuning LMs using a tree of thought style high-level counterfactual decision making. Like that would be amazing. Like you get one of these widely available foundation models and train it to solve complex problems so that it kind of just thinks like that from like the first prompt would be absolutely amazing. But this technique is really cool.
Yeah. I think like to me, like is that thing that I think was very interesting. Like they go into the introduction about this system one and system two ways of solving problem, right? And I kind of agree with that, right? Like how I guess like most like using LLMs is kind of akin to the system one, which is kind of like general knowledge and then just blurbs the thing, and then this idea that maybe this tree of thoughts is more similar to the system two, that's slow, deliberate, and the way they built it, right? So they make like break into small pods, right? And then they try to build, the most promising state, and then go and tries to build that on a tree, etc. I think it's really interesting, right? Because it's really it's another part. I think it's even more similar to what I would classify as, artificial intelligence, instead of just,
Yeah.
is more like, machine learning. Not machine learning LLMs, but I don't know. To me, like this process is more like, oh, it's really like trying to build some something, some reason behind like why it outputs the stuff it outputs, right? So I think that's, to me, was the most interesting part of the paper, right? Because it kind of works. I think I agree with you, Guilherme. Not only the crosswords, but I think all the problems that they put, like, there are problems that are, you kind of can see that, like, oh, you kind of have to break down to solve like the 24 game, right? Because you have four numbers and you have operations for each of the two numbers. So it's kind of, I don't know, it's kind of hard for, just in simple prompting, or I guess the chain of thought to improve much of the prompting and to have good results, right? While then you have tried to break down thoughts, like each thought, I don't know, can be from a previous state that you already did the calculation, right? So it's kind of, I guess, like, is a problem that they made specifically for the comparisons on this paper, right? I think, of course, then you have the creative writing, which was the one that he didn't have much improvement on the metrics, but also it was really uh, like what's the word for, like, when you have like something that's not, like, you can't metrify very well, right? But you can have the number like it's correct, incorrect, right? They used humans to compare the results, right? So it's more like qualitative is the word. So, but it still improves the results, and the crosswords also improve. So I don't know. I think it's very interesting, like this part, like how you can break down in small thoughts and try to solve a problem. And of course, I think on the paper as well. Last thing, Victor, is that, like, they each time they use a different method, right? So they didn't compare the methods of traversing trees, tree size, and stuff like that, because they put like the one that worked for them, right? So, oh, this for 24 we are going to use, I don't know which they use, like, oh, BFS, and the other are going to, oh no, they use, for crosswords we're going to use depth first search. So it still didn't compare this stuff, so maybe it could be like a future work. But also it goes like with they go like their not advantages, but strong points of the algorithm. Like, it's kind of modular, right? So you can kind of tweak and say, like, oh, we're going to generate like how many thoughts, and then we're going to use this algorithm to traverse the tree, etc., etc. But
Yeah. But yeah, this I think I find it really interesting and also inspiring, this that you're saying about um, basing this technique on something that we already find in human cognition. So kind of replicating this in these models led to better results, and uh, making them able to solve tasks that they previously weren't able to. I find that really interesting. And also, it's cool that it's like uh, uh, using classical programming techniques in association with language models, right? It makes me wonder, uh, how much more we could do trying, like, as you were saying, even without changing much of the pipeline, we could uh, try different tree traversal methods and things like that. There are a lot of things that have already been done in these areas that could potentially uh, be used here. So that's also really cool.
Yeah. And also I think another thing is that how they use, right, they go like to identify the most promising state, the voting, and the stuff like the state evaluation, that they use the LLM, right? So it kind of, it's really powerful, right? I think it's something that a lot of papers on previous sessions go into that. Like, they use the result, like the model, you can use the result of the model to kind of feed itself in some way, right?
It's
I
kind of
guess,
self-contained, right?
yeah, it's kind of like
Yeah.
solving a problem. And this, like this part of like this processing of the the evaluation of the state is kind of like solving a problem is hard, but trying to evaluate the steps is a problem that maybe is easier. So we can use the LLM to assess that, right? So it's really, I don't know. I think it's really, I don't know. Something that I don't know. Last year, I didn't thought I would think that would be like, oh, that's very bad practice or stuff like that. Of course, not LLMs, but like other models, like, oh, use the output of the model. It's kind of okay. That's good, but that can cause some concerns. But these
Yeah.
models, they are very good. So. Uh, there is still the concern, right? Because you're kind of dependent on your model, but at the same time, they provide this thing that it's so good, right? You can make stuff that's so much more complex, right? And then of course, then later you can put a human try to evaluate, like separate the state and see, like, oh, it makes sense. This, I guess, could be like a separate step for like using production, right? So like say you sample some case and you evaluate and say, like, do you agree with what the output of the model, like for this thought or this anything else? But yeah, I think this is also really interesting, right? They use this to break down the problem so they can evaluate, say, now how good, how impossible or not possible, how good or bad, how to vote, etc.
Yeah, this loop is really interesting. It almost looks like self-awareness, right?
Yeah.
Like you create all these thoughts, and then you kind of talk to yourself about how good they are, if they make sense. I mean, yeah, that's a good point.
Yes. Any other comments, guys? I put on the document of the session, some of the links that I think are interesting. So, and also there, like the paper, but also the a website like that's really good for prompting engineering. So I really recommend going to the document, but like this one, learn prompting. So it's kind of good. Like I don't know, they I guess they update it quite frequently, but I guess it's really to me it's a good website to see some techniques how the gist of it works, right? And yeah, and also I think also the last part, I think also it was really interesting, like this Gubix website that they have. I was looking, right, just curiosity, and I thought the game was kind of fun, so I played a bit, and then I was like, okay, I have to stop playing because it's kind of addictive. Uh, but yeah, maybe I guess that's it, guys. I think it's really is something that really we can try to think about, like maybe some problems that are more complex, and current LLMs don't solve our problem. Like maybe we could gather some stuff, some ideas of this prompting, even though it's not the full tree of thoughts. I guess it could be interesting for Claudio, etc. Of course, there's the thing, right? Because he's evaluating each state, creating each state. So I suppose they don't give a metric, but I suppose it's kind of token intensive, right? But I think it's
Yeah,
like
we tried to do something using different models. That was basically the idea for taking GPT-3 and then using 3.5 to evaluate the response and edit based on any new information that might come up, and GPT-4 to just do the final edit as well. But it's kind of hard to implement when you're working on the token limit. That's the kind
yes.
of limitation I think of these, which is because it's interesting. I mean, it's what computers are traditionally good at and humans are bad at, right? This kind of like thought, like steps by step approach. And it still fascinates me that LLMs are very, very good at what humans are good at, like creating text and language and making coherent sentences, but not information.
Yes.
exactly like humans.
And also this part, right, that you said, right, they create the thoughts, right? So it's not like, it's not trivial to think, right, oh, this potential solution is this and that, right? Of course, they can be totally wrong, like, hallucination is a problem for LLMs, but also it's something that other models, it's kind of a new problem, right? Don't have, like, I guess, something similar to LLMs in that way, right? I also posted on the thing, like, the authors released they changed their account name. Okay. Oh yeah, they go with Princeton LLM, but NLP. But they have the official implementation of the code. It's by the authors. They have, like, a note here that some other guy created a repo unofficial that apparently doesn't work. But yeah, I think it's interesting. They also have the prompts. I just had a quick look, but we could look into that also to think of ways that maybe improving CloudWalk in some way, or any other problems. I think we had, like, problems that could be interesting to do some testing on our side, besides talking to people. But yeah, I think it's really interesting, really good presentation, Guilherme. I think I don't know, I'm curious to think about, like, the new ways, right? Because this paper was published, like, on archive on 17th of May. So, and the other papers, chain of thought, was like late 2022, I believe. The other chain of thought, self-consistence, also shouldn't be too way before, should be between end of 2022 and May 2023. And, like, it's like, what, 6 months. So, and it's really a lot of papers and a lot of ideas regarding this area of prompt engineering, right? Because it's kind of like a new area as well.
Yeah, you get a list of the most cited papers from the last year or so, and almost all of them are related to LLMs. It's really
Yes,
interesting.
it's the new hype. uh, okay, guys. So, any other comments, questions for Guilherme?
One thing I found really interesting, like why they were using BFS for some tasks and why they were using depth first search for other tasks. Like I'm somehow, like, I have an intuition why BFS would be better for something that's like for the game of 24, because like you're doing a look ahead and you're trying like to predict what's gonna come in the future, and the more options you have is like the better. But yeah, I want to hear like more on that, if they've like explained in some way like the choice of the algorithm and the like hyperparameters of the algorithm in any way, because it kind of felt arbitrary as I read it.
Yeah. Like, to me, is your point, right? They didn't, like, they didn't test, like, they didn't compare, like, oh, this for this game, this one works better or not. They just put, like, I guess they try tested, but then they say, like, oh, the best one for this one is PFS. For the other task is because they test, right? I don't remember here, but some of the tasks were solved with PFS, the others are with TFS. But yeah, like, it's something that they didn't show, like, why. I guess they just guess, like, oh, maybe this one will perform better, and they didn't test the rest. But yeah,
I
it's
mean,
something that they
in the
could.
crosswords, I think it quite makes sense, right? Choose that first, because you have one like single correct answer, so you don't. I mean, you don't need to take into account many of the thoughts in that step if the thought that you got here is the correct one, right? I think. But the game of 24, I don't know. Yeah, it would be cool if they had used both searches and put the results.
Yeah, maybe it'll be a future work. They do some ablations tests on this and say like, oh, you can do this or that, or because yeah, to me they had the idea and then they tailor made the, the the algorithm to do that, right? So like, and also because it's also the depth of the tree, also this other kind of stuff is they just say
Yeah.
like, we use this, yeah, believe on us that improves the results, but because it's something that like the depth of the tree would really impact like the usage of tokens, right? Because if you have like a deeper tree, I guess it would be better, but also it would have to go to more states. Of course, also the search algorithm also impacts on that. But yeah, like it's something that maybe is a future work, like someone will get this and try to evaluate these other aspects like token usage or how much computation you need to use it. Some problems because also this is kind of it's kind of hard also to generalize, right? Because you have the problems, but how would you compare also, you know, like 24 game like problems and like crosswords like problems also it's kind of complicated also to think of this like to have a general answer also, I guess.
I guess it's more about like thinking mathematically in some of them and just bringing examples of like mathematical operations. And in others, I mean, crosswords are what? It's a semantic game, right? Where you're playing with like word meanings, but at the same time you're very bounded by rules. So I think they chose like one task for basically everything they could think of, like general concepts. It was the game of 24, creative writing. Yeah, so very mathematical, very creative and very open, and then kind of like in the middle, so creative but semantic, but with constraints. So I don't know if I think it was kind of a good choice of problems just to demonstrate a technique, right?
Yes,
Like,
yes, yes.
but like you said, I mean, they could do it. They could try doing this exhaustively, and it becomes a more quantitative research. Might be interesting. Maybe there's diminishing returns with depth and branches. Who knows?
Yes, yes. Yeah, but maybe later, like it will be like another set of they someone will create like another metric like glue and others like to assess language. Like glue is like language understanding and evaluation. I don't know, and some like tasks, like issues and tasks, like so we can try to evaluate like these more complex problems, so like problem solving as a prompting. Yeah, and also there's a lot of things that we can think about because also you can think about the model itself, right? Because they are using GPT-4, but is other models better and stuff like that. So I think we are really like in this like lots of new things appearing, but I also think that later like you have some more standardization, so have more like this like, testing more like yeah, be more standard how to compare stuff, I guess. Because also if they try, because we don't have any standard, right? So if the guys try to come up with a standard, I guess they would take so long that the area is moving so fast that another person would have some similar idea, I suppose, and they don't want that, right, to lose their work, I suppose.
Yeah, maybe if it's a mixed task, something that involves different kinds of reasoning, uh, separating the process into different steps, intermediate steps, would allow you to kind of give each of these steps to the model that better performs at them. So that's something I was thinking as well. Maybe you have a model that is fine-tuned to um, perform better at mathematical reasoning, for example, right? Another one that is better at creative writing. And if it's something that takes both those things, then maybe you can separate the task into intermediate steps and give each model what they are best at doing. Something like that.
Yeah.
But yeah, involving programming, I think in this pipelines, I find it really cool. Could be very promising, I think.
Mhm.